Hello viewers, I'm Maitli. Today we are going to see 10 Cbse maths in triangles basic proportionate theorem, which is also called as BPT theorem. We are going to see in this video the basic proportionate theorem, which is found by Thales. It is also called as Thales theorem. Now let me see the statement. The statement is, if a line is drawn parallel to one side of a triangle to intersect the other side in distinct point, in any point, distinct point means in any point the other two sides are divided in the same ratio. Here in a triangle, if a line is drawn parallel to one side, these two are parallel to one side of the triangle to intersect the other side. Here from D it intersects at E. The other side are divided in the same ratio. So that means these two are divided in the same ratio as this side. Now before seeing the proportionate theorem, let me teach you two things which you have learnt in the smaller classes. Here it helps you a lot in this theorem. Now this is a rough one. Don't write this in your exam. Just for you to identify. Here I am taking a triangle ABC. If I take this triangle ABC, I am drawing a perpendicular line from A. So, what is the area of the triangle? Area of the triangle of ABC is equal to half into base into height, that you know better. Half into base into height means here base will be BC and the height will be AD. This is your area. Can I write this to be half into AC into AD? Even this is a base. If we take from this side, this can be a base of a triangle. So base into height, this is correct? No, because for base means the perpendicular line should be on the base. It is called the base. Yeah, for base, if I take this to be E, my area of a triangle can also be written as half into BE into AC. Half into BE into AC. That means in the base there should be a 90-degree line from the vertices. It is the height. So your height H and B are the height B on the base of the line. So if we can write this triangle in three ways, the area can be written in three ways. If I take this to be F, my area can be half into base into this side. I can't take this side BE. Where you taking the base, the line should be 90 degrees. So half into base into height is half into base is BC, height is AD. Same way here, half into base is AC and height will be BE. Same way on this side, half into base is AB, height will be AC. This thing we have learnt in the smaller classes. Just I want you to refresh it. Now I am taking a triangle like this. As I told before, your angle should be 90 degree on the base. If this is my triangle ABC, I want my base to be BC. If my base is BC, I can't draw a 90 degree inside the triangle. If I can't draw a 90 degree inside the triangle, the perpendicular inside the triangle, then we should extend the line. We can draw it on the outside the line. This will be my height. AD will be my height and BC will be my base. So I can write the area of the triangle to be half into base is BC, height is AD. It is not from DC is not your base. Your triangle size is from ABC, so it will be only BC, and your height can be taken outside the triangle if you can't draw a perpendicular inside the triangle. So remember these two things, which is going to applicable in the given proof. Now we'll go on to our 10th standard portion. So we are going to prove this BPT theorem. We'll start with the given. Here in given, they have given in triangle ABC, only one thing is given, that is DE is parallel to BC. In triangle ABC, the given item here is DE is parallel to BC. So now the proof is, sorry, let me write to prove. Here we need to prove they are divided in two equal ratios, so that is nothing but AD, this side by this side, AD by DB is equal to AE by EC. So AD by DB is equal to AE by EC. This is what we are going to prove it here. Now let me write the construction. We are drawing a perpendicular. EF is perpendicular to AB. Same way this side we are drawing a perpendicular, that is DM is perpendicular to AC. And also we are joining DC and BE. So we are doing some construction, that is we are drawing one perpendicular from E to BAB, same way from D to AC. So this is our construction. So we have written the given to prove and also the construction. Now let us start with the proof. In proof I am taking the triangle ADE. So in triangle ADE, I am going to take the base. Because of this I want AD to be in the proof, so I am taking the base to be AD. If in the triangle ADE, if this is my base, my area of a triangle will be half into base into my height, the 90 degree comes here, so this will be my height of the base AD. So your area of triangle ADE is equal to half into base here is AD, height is EN. So now I am going to let me take this to be equation 1. The same way I am going to take this triangle, because I want the base BD, so or DB, so I am taking this triangle. The same way here, if I take this to be my base, I want a 90 degree over here. I can't draw a 90 degree over here. What the reason is given here is, if I take the base, the 90 degree can be outside extended line from BC. Same way, if I extend this line, my 90 degree will be here. So I can take this EN to be the height of the triangle. So it can be outside, the perpendicular can be outside, but it should be on the extended base. So in triangle BDE, area of triangle BDE is equal to half into base is BD. As I told before, the height will be outside EN. I am taking this equation to be 2. I am dividing equation 1 by 2. If I divide, I get AD by BD or AD by DB. So I am dividing equation 1 and 2. Let me show you. Dividing equation 1 divided by 2. Now LHS, you should divide with LHS and RHS with RHS. So area of triangle ADE by area of triangle BDE is equal to, here it is half into AD into EN. Here also it is half into BD into EN. Here half gets cancelled, EN gets cancelled, the rest is AD by BD. So I am taking this equation to be 3. Here it is the area of triangle ADE by area of triangle BDE. Now let me take the triangle this side. I'll just draw a rough figure here so that we can see it here. The same diagram I'm drawing here. ABC. Here it is. Here I've written this to be MN and it is perpendicular. I'm just joining this two. Here it is DE. these two are parallel. This is what the diagram I've drawn it here to show you. I'm drawing it here. Now let me take this side. As I want AE and EC, I'm drawing it to this side. I'm taking this side, area of a triangle ADE, same area of triangle ADE. In triangle ADE, area of triangle ADE is equal to, same way, half into base into height. If I take this to be my base AE, my height will be the 90 degree on it. So this will be my 90 degree height. So it is DM. Same way, as I want the base of this as CE in the proof. Sorry, in the to prove I want CE. So I am taking this triangle. So in triangle BEC, area of triangle BEC is equal to half into basis, as I told before, it is EC, height is the same way, the height can be outside from the extended one. So sorry, for EC it should be DEC. DEC from the vertices to the extended line, so it is DM. Now let me divide the fourth with the fifth. The same way, if I divide, I'll get EC by AE by EC. So dividing 4 divided by 5, I get area of triangle ADE by area of triangle DEC. Here it is half into AE into DM by half into EC into DM. Here this 2 get cancelled and this 2 get cancelled. We get AE by EC, which is area of triangle ADE by area of triangle DEC. Let me take this to be equation 6. Now check your 3 and 6. In 3, we have area of triangle ADE on your left hand side. The same way, even here we are having area of triangle ADE on your left hand side. Now on the denominator, we have area of triangle BDE. Here we have area of triangle DEC. Now let me check the diagram of BDE. BDE is this triangle and DEC is this triangle. We have learnt in 9th standard that these 2 lines are parallel. Let me draw it again for you. Here this triangle and this triangle. Here these 2 lines are parallel. We want the triangle here. We know that in the 9th standard we have learned that if 2 triangles on the same base, here the base is here, this is the triangle and this is the triangle, on the same base, between the same parallels, then their area will be equal. We have learned this in 9th standard, that is area of triangle. We can write it, they are equal, then we will write the reason. BDE is equal to area of triangle DEC as they lie between same base and same parallels. So they are equal. If they lie between the same base, if they lie on the same base and on the same parallels, then they are equal. The area will be equal. From this we know that these 2 are equal. So ADE, this LHS is equal to LHS because numerator is equal to the numerator and denominator is equal to the denominator. So if your LHS are equal, then we can directly say your RHS will be equal. If the LHS are equal, then your RHS will be equal. We have proved that the numerator is equal to numerator and denominator is equal to denominator. So this side is equal. So we can directly write, let me take this to be 7 from 3, 6 and 7. From this 3 part we can say that they are all equal and therefore AD by BD or DB, whatever we want, we can write, it is the length, so it is same if we write DB or BD. So this is equal to AE by EC. Hence we have proved the theorem. For theorem, the statement is very important, the diagram is very important, given to prove, proof, construction, everything should be same as in the book. You need to write all the each and every part of the thing. Even the statement, you can't change any letters or words. It should be same as in the book. So that's all with the theorem. Thank you.